Okay, so for 8th grade, this is from April 5th, 2022. These are our notes on manipulating with scientific notation. Today we covered adding, subtracting, and multiplying and dividing scientific notation problems. So the first thing we did was adding and subtracting, and this one's pretty easy. This one, simply convert your numbers into standard notation and solve like normal. So if I have a crazy big number, I would simply convert it and then solve it like normal. Uh, Typically, in word problems, these will appear as problems phrasing as how much greater or how much larger is something else than another quantity. That is how this will often appear. The second type of problem is multiplying, and this one won't typically come up too frequently, but it does happen. Multiplying is going to be step one, you multiply the decimal part, and I will have examples at the end. But you will multiply the decimals. So in this example, we would multiply 4.2 times 9, and then use the product rule for the exponents, meaning we will add our exponents of 4 and 12 for the times 10 piece. All right. And the only way I have really seen these types of problems come up with any amount of frequency is this. Usually they'll be talking about a rocket or airplane, something that is traveling at a very high speed or a very low speed, like a snail. And it will say like a rocket is traveling at 4.2 times 10 to the fourth kilometers per hour. I don't know how accurate that is. I just made this problem up off the top of my head. It must travel 9 times 10 to the 12th kilometers. How long will that take? I suppose I should have phrased it as how long will that take in hours? So in this problem, we would multiply our rate of travel, which is 4.2 times 10 to the fourth, times 9 times 10 to the 12th. That is how we would do this sort of word problem. But you should know this is relatively uncommon in problems that I've seen. Division, on the other hand, is very common. For division, it's a similar process. You're just going to divide the decimals and then use the quotient rule for the exponents, meaning you will subtract the two exponents. So down below, I put a few examples of how to do some of these problems. So the first one up here at the top is subtracting your scientific notation. So we started with 1.7 times 10 to the sixth minus 1.2 times 10 to the fifth. That equals about 1,700,000 minus 120,000. And off to the side, we just set it up as a normal subtraction problem. We had to do a bit of borrowing, and we got our answer as 1,580,000. That's really all that's going to happen for those types of subtraction problems. Down below that, we have a multiplication problem. In this case, we took 2.1 times 10 to the fourth times 1.2 times 10 to the third. And it's the same process as in our notes, as mentioned up there. All you are going to do is you are going to multiply your decimals. So 1.2 and 2.1. We have our multiplication down here. The answer would be 2.52. So that is going to be the number we put here. Then we have to deal with our exponents. We have 10 to the fourth times 10 to the third, which would give me 10 to the seventh. And I just stick that there. Done. No need to do anything else. There is a second way that does technically work, but it is going to take a lot longer. If you really, really hate this process and don't want to deal with decimals as much, you could, I suppose, convert both of those numbers into standard form and then actually multiply. What would that be? 2,100 times 120? Or no, I'm sorry, 1,200 times 21,000. You could go ahead and write that out and then just add the scientific notation piece at the end. But I'm going to tell you right now, that takes a very long time. I would not recommend it. The last example that we went over is what to do if it's division. Now, division problems, very frequently, if they're not in word problems, will be written out like this. In this case, I did 4.2 times 10 to the sixth divided by 2.1 times 10 to the fourth. It won't always be this straightforward, but I wanted to pick a relatively straightforward division problem. So we have 4.2 divided by 2.1. I have my setup right here. A reminder, you cannot have a decimal in the divisor. So that has to be moved over once to get rid of it, which means it also must be moved over once on the inside. Okay? We then see that 21 goes into 42 two times with no remainder. So my whole number will be 2. And for my exponent, I just do 6 minus 4 to get my exponent of 2. And that's it. Those were the notes that we took on manipulating exponents and manipulating scientific notation. And yeah, I believe those were the last notes of this unit that we will be taking. So from here on, it is only review. Good luck.